So this is expert founder and you're watching on YouTube. So in this video we are diving into one of the most fundamental linked list problems from the Leetcode. Reverse a single linked list using the three-pointer approach, and we'll see in this video. Okay, so the question is a Leetcode 206 reverse linked list problem, in which we have given the head of a single linked list and we have to reverse the list and we have to return the reverse list as output. For example, we have given this example 1, and input we have given head, and it is a linked list of one of the array. You can say 1 2 3 4 5, or you can say linked list, right? So 1 points to 2, 2 points to 3, 3 points to 4, and 4 points to 5. So this is a single linked list, and so we have to return in the reversed list order. Okay, so if this is a list, you have to return as a this list. Okay, means the Leetcode 206 problem asks us to reverse a single linked list, right? And the given linked list is 1 2 3 4 5, right? And after 5 it is null, so we need to reverse it to 5 tends to 4 tends to 3 tends to 2 1 and null. Simple, right? But how do we do this efficiently using the Java program that we will see in this lecture? Okay, so as you can see, the first example that we have given, so 1 2 3 4 5 we have given, right? The head we have given is 1 2 3 4 5. So this is the linked list we have given, and we have to return in the reverse order. Okay, I hope you understands the linked list, right? So linked list contains multiple nodes. Each node is connected by you can say link, and this link is connecting one nodes to other nodes, right? And if there is no node behind and next, means it is null, right? So we have to reverse it and we have to show it like this. Okay, so the cleanest way to reverse a linked list is using the three-pointer technique, right? And we will use the previous, current and next node to track. So what is the previous node? So for, let's suppose for 2, the previous node is 1 and current is at 2, and so the next node is 3, means 3-pointer will take and we'll do something like swapping, and we will break the link and we will preserve the link. Like those things we will do, and will do means the previous we will use to keep track of the previous node, current will process the current node, and the next node is to preserve the next node before breaking the links, right? That we will do. So don't worry, we'll go through the intuition, then we'll go a couple of examples, and then hands-on coding we'll do. Okay, so what is the intuition we have for this problem, right? So the intuition is very important to understand before writing the code. So the intuition behind reversing a linked list is simple. So you want to reverse the direction of all the next pointer in the list so that every node points to its previous node instead of its next node. Okay, and so we will use the three-pointer approach, or you can say iterative in place reversal, right? And for that, the 3 key pointers are for each iteration that we will use in the loop is previous, current and next. As I told you, previous we will use to point to the previous node, and current we will use to point to the current node, and next node, it is like a temporary store the original current node next, but we don't lose it because the rest of the list we will lose it, right? When we are reversing the pointer. So let's suppose if this is your list, right? If 1 2 3 4 5 we have given is the list, right? And we want to return in the reverse order. So what we need to do? So before iterations, we have to initialize these 3 variables, and we have to initialize the value, right? First we will declare this. So all these are nodes, right? The previous node, current node and next node. So the previous nodes, initially we will point add to where? To the null, right? Because the previous node is null and the current node we will head points to the head. So this is your head, right? And so the current will be at head. And so what will be the next? The next node will having head dot next, right? Or you can say current dot next. So we will the current dot next we will save into the next node. Okay. Why we'll use the next node? Means we want to store the next node temporarily. Why? Because if you want to break this link, let's suppose if I want to break this link, I will point this to this side. Means I want to point to null, right? Means we have to break from here to here. So at least the next node will contain this node. So from the next node we can traverse to the rest of the node, right? All this rest of the list, because if I will break this one, right, so this will be independent and this part will be independent. So somewhere we have to store this part so that we will not lose the data, right, of this list. So we will store on the next one, right? So once we will set current dot next equal to the previous, right, means we will break this, so it will be independent, and so we should store this value somewhere and we will store at here. So current dot next we will save here, where? At the next, and then this data we will save, right? Now think about the current situation that we have. We have done one rotation. This will points to null, means the current that we have has we have set to the where? From 1 to previous, because we want to do reverse, right? So now 1 will points to previous and previous is at null. Okay, now think about the current. Where was current? Current was here. So now we have moved current from, because we have reversed it, right? So now the current will move, right? And so we will move previous to 1. This will move to here at this point, right? And then current will points to 2. It means if I'll go here, like this. So you can remove this part for now. You got the point, right? So it will look like this. Okay. So now the current we have moved from where? From null to here. Got the point, right? Means previously before any iteration the previous was at null, but now after reversing this 1 points to null, right? And so we will move from previous from here to 1. Okay, now the previous will points to 1. So the where will the current go? So current we have to move from here to here, because this part is done, right? Now we'll do for this part, right? The rest of the part that you are seeing from here to here, right? And this part, who has saved the data? The next, right? So what we will do, we will update current from here to here, and so the current will points to 2, and we have already set this previous at 1 and current we have set to 2. Then what about the next node? So next node, because we are current is at 1 at this 2, it means from here to here it can be lost if we will not save the data, right? So from this is the current, right? And from here, right, we have the next node, right? So next node will store here. So how we'll get this from here? So 2 dot next, because current was at next node was at 2. So we will save the data from we will move from here to here, and to do that we will do what? This point 2 dot next, and it was called what? next, right? Next node, next dot dot next, next dot, next node dot next will come to here, right? So this part completely is independent, and that is stored on next node. So we can break this part now. You understand, right? So the first part that we have break is this one, and so before reversing, this part we have saved on the next node. Now the same thing we will do, this part we will save on where? On the next node, right? And this, as previously the one it was current was at here, similarly we'll put the current as written. So before that, like for this we have put the null as a previous. Now for these two we'll add one at this previous, right? So previous is set, current is set, next node is set. Got the point, right? So you can see here, right? As I told you, the next node is equal to 3, and so by how we will go there? Because we do 2 dot next. What is 2? The next node. Next node was here, right? So 2 dot next means this was, next node was here. Who will set? 1 we will set, right? And previous will become what? 2. Current will become what? 3. So for 2 dot next we will break from here and we will set here. Like for 1 dot next we have done what? We have set null. Similarly we'll do 2 dot next, we will break this link and we'll keep this link here, right? And the same thing will keep doing until we will reach here. Once we will see that the this value, right, 5 dot next is null. If this is null, we will stop there, okay? And until we'll reach there, we will reverse everything, right? So you can see we have all this data here. Like previous will be at 5, because if you observe that previous is moving, right? So it will keep moving till the 5th here, and this part will be reversed, already reversed, right? And so previous is at where? At 5, and from previous means 5 dot next is null. Then we will stop. Why? Because current and next node is null now, right? So let's get our hands dirty. And so as you can see, we have given this list node. We have val, we have next, we have node constructor, and other constructors are also there, okay? So we will use this accordingly, okay? So first of all, think about the implementing this function. So what we have given? We have given this list node, the head means this head was given, right? So if you'll talk about this head, means this head is a list node. So list node contains the value and the next. What is the value? So 1 is the value. What is the next? This link. And at this link at next is also a node. So this node will contains what? The value and the next, right? Like that, these data are there on each node. The first thing that we have understand, right? Now think how we are going to move, right? So we are using 3 pointers, right? That we will define here. So let's go and write the 3 pointer. So first we will write previous, okay? And this is null. Then we will define what, why we will define the null, right? Because no initial value at previous node, right? So at previous node there is no data is there, right? That I have shown you in the example, right? Now we'll use the list node and we'll write the current. So there will be a current, but current will points to the given head, right? So as I told you, initially the current was at where? At 1. So we'll points to 1. Now we'll make till the will reach to the this location, right, at 5, and after 5 is what? Null. So what we will do, we'll say while current is not null. Until current is not null, we have to run this loop, right? So what we will do in this loop until we reach to the 5, right? Because the current is at where? 1. It will keep moving till the location 5, right? Till location 5 will reach. What will happen? We'll keep the loop running, right? And so we'll define in the loop, we'll create a third pointer, right? So we have created the previous current. Now it's time to create the next node, right? So next node is very important, okay? Or right, you can write next node, okay? So next node is very important because now initially current is at 1, so next node will come where? Current dot next, means we will come to 2, and so we'll write the current dot next to reach at 2. You understanding, right? We have to store the next node. Otherwise, if we will remove this 1, after 1 there is a link, right? If we will remove this link, we will lost the data from 2 to 5, and so that we will store the temp. So the next node is nothing but the temp, right? Temp node. So then we can store after the current, right? After the current is current dot next, right? We'll keep all the list data after the 1 to this node, right? You know the swap, right? We used to swap the data, so we will use to write 3 things, right? Let's suppose A have 5, right? B have 10. Then we used to write what? Temp, right? So we used to keep the temp at A, right? And then we used to write B is equal to A. No, first of all we'll write A equal to B, and then we used to write what? B equal to temp, right? So if we want to swap these two value, means A I want now 10 and B want 5, so that you have to create the A, so that temp, you have to create temp, so that we can store the value of A, and then we can replace the value like this, right? So similarly, this is your temp, right? Means rest of the data after the 1, right, we have to store, right? So that we will not lose the data. You got the point, right? Now we'll write the current, right? So write the current dot next. So now current dot next is what? Is previous, right? Means we are removing the link here, right? So this link will move and it will go back to the back, right? Means 1 will points to the previous, that we will done. Means we are reversing the we can say reverse the current node pointer. I will write clearly. I'll show you again. So just give me a second. So I will go through. I can explain the code again. Don't worry. I will explain again the code. Okay. So we have stored. Now we have reversed the current pointer, right? Now what is at previous? Previous is nothing but a null. So now previous is at current, because we have to move the previous also, right? So previous is current now, means we have moved the previous pointer to the current node. Okay, this thing done. Means first one it was pointing to the previous, now previous points to 1, right? And we have saved the data, we have reversed the point, and then we have to done that. Okay, now what is pending? Now pending is one thing, right? What is at current? Where will be the current, right? So that we have to write. So now current is at 2, and for that the current node, who is at current node, right? So the next node is at the current. What the point, right? Means move the next node. Now when we will update the current at next node, means now points to 2, right? So now the current will move to 3. Sorry, current will be at 2, but the next node will move from 2 to 3, right? That I have shown you in the slide, right? We'll go back to there and we'll talk about there. Okay, now what is we have to return? The previous, because we have to run until the current is not null, means we'll reach till here 5th, right? But the previous is at what? At last, right? So we have to show previous and current will be null, and so we will return previous. Okay, so why we are returning the previous? Because previous pointer will be at the new head of the reversed list. Okay, in the reversed, you check the function, right? What reverse? Okay, reversed. So let me run this code. Let me submit this. Okay, so it's running. Yes, we have set to null. Current is at 1, so given value at current, right? And the next node is at 2, right? So what we have done here, previous we have set null, current is at head, means at 1. Now we will run this loop until we'll reach to the 5th node, right? What we will have at the next node? So next node is at current dot next, means at 2. So we will do current dot next, means at 2. So now it's time to reverse the node, right? So our current is at here, right? So when we are doing reversing, now we will set this value to null. So current dot next, we are not moving, we are not keeping like this, we are reversing. So now we are doing what? Current dot next is previous. Now we are moving previous at what? Current. And so this next node will move from here to here, and the current will move from here to here. So this part we will do here. Means the next node is at 2. Why? Because current was at 1. So current dot next is 2. Now current dot next is what? Previous, right? Means now current dot next is previous. Okay, and so it is reversed now. Now previous is at current, and so current is at next node, means at 2. From 1 to 2. Now the next loop will happen. So first we will do what? Next node from 2, current is at 2, then we'll move to the next. So we'll store 3 here. Like that we will keep going that until we'll reach to the 5th node, and finally we'll return previous. Okay, so the thing we have to do is we have to write 3 pointers: previous, current, and next node, so we can store the half of the node, right? Means why we are storing here, let me show here. Okay, so why we are taking the 3 nodes? Because previous we are storing at the null, right? But current we are storing at this value. So if we will remove this part from here, right, the rest of this part should have stored somewhere, and that is why current dot next we are saving at next node. Okay, so each time the next node will store half of this data, right? And the current will store the current position at this part of node. Let's suppose we'll reach to the 4th, right? So from 4th, right, this part will call next node, but from this to this part will store at the current. Okay, I hope you're understanding, right? It's still, so thank you guys, thank you for watching this video. Let me know in the comment box that what is the time complexity and space complexity for this, and I hope you understand the video. And if you any doubt, please ping me in the comment box, and please subscribe this channel for more updates. Thank you for watching this video.